Hey everybody, today you guys are going to be taking some notes on exponential functions. You should have already completed the first 3 pages of the notes, and you should be on the back page now. So 2 parts of the notes today. The first part is our general form for an exponential function. We have some value a times some value b to the x power. So a is going to be our initial amount that we're starting with, and b is the growth factor. So what y changes by as x increases. So are we doubling the amount each time, or are we halving the amount each time? That's what b tells you, and a tells you what you started with. If the b value is greater than 1, you're going to have a situation where you have exponential growth. So it's going to have the general shape increasing to the right, decreasing to the left. If b is a fraction between 0 and 1, you'll have exponential decay, and the graph is flipped the other direction. Just like other functions we've dealt with, we can transform exponential functions. A, which we call the initial amount, is still the stretch, so it tells us like how far up the y-axis this graph is stretched. If you have a number added or subtracted to x in the exponent, so it's just up here in the exponent place, that's our horizontal shift. And it is opposite, just like always. So if it's -2, that means right 2, and so on. And then the plus k at the end is the vertical shift, and that's where the vertical asymptote is. So if I had a graph that was, I don't know, y equals 2 to the x plus 3, the graph will have an asymptote at 3 and do something like that. I'm going to go ahead and go through the example problems with you. So if you want to try these on your own, go ahead, pause the video, come back and look at this. So let's go. So write an exponential function to fit each of the following descriptions. Check your answer by graphing it in Desmos. So a function that triples, that's telling me the b value. And it goes to the point 0, 5. 5 is going to be my initial value. So that means a is 5. So this looks like y equals initial value of 5 times 3 to the x. Transform your function so that it has an asymptote at 4. So I'm just going to take that function that I wrote and add 4, because that'll shift my whole graph up 4. Problem 2, use the sequence to the right to answer these questions. So write an exponential equation. So to write an exponential equation, if you're given a sequence, this is your initial value, so that's your a value. And to figure out b, we want to figure out what's happening to go from one number to the next. So to figure that out, I could take 9 and divide by 20 to figure out what we're multiplying by. And it's going to be a fraction because it's getting smaller. And that gives us the fraction 0.45. And we could double check to make sure this is an exponential model. You could do 4.05 and divide by 9, the previous number, and you'll still get 0.45. So that tells me that 0.45 is the b value. So our function is going to be 20 times 0.45 to the x. Graph the equation, so graph these points that you're given. And they're going to get closer and closer to 0 the further we go to the right, indicating that there is an asymptote at 0. So the y-intercept is 20. It's 0, 20 if you want the point. The domain is negative infinity to infinity because it goes left forever, right forever. The range is from 0 to infinity because there is an asymptote at y equals 0. Okay, last problem. You're given a table. We want to figure out the missing values here. So we want to figure out what's happening each time as we go across from one value to the next. It looks like it's increasing by a factor of 5 because it's times 5 each time. So that means that if I go backwards, j has to equal 3. So that when I multiply by 5, I get 15. And 375 times 5. K is going to be 1875. writing an equation, y is going to equal our initial value. That's our y-intercept, where x equals 0. 3 times 5 to the x. Feel free to send me an email if you have any questions or need any help on your homework, and have a good rest of your day.